And welcome everybody to the Daily Space Weather. We're looking at the sun here in ionized helium, 304 angstroms from the Solar Dynamics Observatory. To see a new sunspot group form, Sunspot 2830, it's this bright spot down here. Sunspot 2827 still in effect, as well as Sunspot 2829. We'll show you more in-depth analysis of that momentarily. So here's the SDO intensity gram, and you can see some migration. So first of all, the trailing South Pole-oriented umbra here on Sunspot 2827 has migrated to the south of Sunspot 2827 and largely evaporated. That looks like it's going to be reclassified as an alpha class sunspot later, as it only has one umbra now, it looks like. Sunspot 2829 looks like it may be turning into an alpha class sunspot as well. And Sunspot 2830, which is right in front of my pointer here at the end of the clip right there, you can see that forming. That is already a beta class sunspot. Likelihood of solar flares went up a little bit, despite most of the parameters for solar activity going down. So here's another full disk view in 171 angstroms. Ionized iron from the SDO. And we'll also show you the 193 angstroms animation here. And we've got two coronal hole systems. One is expected to send some solar protons our way, expected to arrive on about the 8th, midday on June 8th. Also another coronal hole associated with the North Pole up here, just sort of rotating into view. Here's a diagram of the solar system. There's where things are expected to be in a week. And here we've put up a star chart as well. This is what the sky looks like above my head right now. We're located in Lehigh Valley, Pennsylvania, and if you want to make your own star chart, head to in-the-sky.org, put in your location. I've drawn in the ecliptic. If you're up before dawn, you may see Jupiter and Saturn and the moon up there, rising ahead of the sun. The radial flux of the 10.7 centimeter variety, 2800 hertz, that is at only 74 solar flux units. And here's the one-year chart of that. As you can see, cycle 25 off to a slow start. The black line here is the radial flux. It is the most proportional number that there is to sunspot number, which is the red line down here. And taking a quick glance at the Space Weather Enthusiast dashboard, you can see these couple of periods of geomagnetic unrest forecasted by NOAA here on the 8th. So in about 2 days and change, we're expecting to see a coronal hole wind stream. I would tend to agree with that forecast. Next, looking at global seismicity, we saw some interesting quakes here near the Salton Sea. We'll get to it. Here's the Volcano Discovery 90-day chart in bar graph form. And here are the only 5+ magnitude quakes. There we've added the 4+ magnitude. And here is this 5.3 magnitude quake here, right near the Salton Sea. So right at the shore of the Salton Sea there was that 5.4 magnitude quake. We also saw some aftershocks from that. There's the zoom out to the location of that mid 5 magnitude earthquake in California. I'm just going to scroll up the list here. And if there's anything of note that you would like covered, just leave it in the comments. We don't want the video to be too long, and there are a lot of aftershocks here. A lot of quakes stretching all the way from California up to Oregon. So a ton of activity kicking off there. There's also a 5.3 right in that same area, southeast of the Salton Sea. And leave us a comment if you felt that earthquake. We're always interested in what our viewers are up to. So that's a pretty significant story there, folks. An extremely deep quake did come in the Fiji region at over 600 kilometers depth and a 4.5 magnitude. If that was at the surface, that would be like a 6 magnitude quake. Again, the depth of that one estimated to be over 600 kilometers. Deep quake struck Chile also at a 4.1 magnitude. Also, we saw a 5.3 at Ascension Island in the Central Pacific, right on the equator, actually. Right on the equator at Ascension Island. The Philippines also saw a 5.0. I thought that was going to say Santa Monica, California. It's Santa Monica, the Philippines. Also, Iran saw a 5.3. Some more quakes off the coast of Oregon as well there, where we saw a 5.9 just a few days ago. Indonesia also saw a 5.2 magnitude earthquake. Volcanoes are next on the list. Abico's been erupting, producing a 12,000-foot ash plume. Please don't hang glide the caldera. Suwanosejima, producing a 7,000-foot ash plume. Please don't square dance around the caldera. Mount Ibu, exploding. It's producing a 6,000-foot plume of volcanic ash. Please do not attempt to do the Fosbury flop over the caldera. Semeru, don't attempt to do the triple Lindy over the caldera there as it's exploding and producing a 13,000-foot plume of ash. Tukono also exploding, 7,000-foot ash plume there. Kerinci now back on the list on the Isle of Sumatra as it explodes, 13,000-foot ash plume there. Sangay exploding in Ecuador as well as Revenador. They're producing 20,000 and 14,000-foot plumes of volcanic ash respectively. Sabancaya in Peru also exploding, producing sporadic puffs of volcanic ash up to an altitude of 25,000 feet, and Nevados de Chilean exploding. Intermittent pulses of volcanic ash have produced a 12,000-foot plume of ash. A great reminder to not pole vault the caldera. This public service message, as well as links to purchase merch themed thusly, available at smAshomash.com. You can get redirected from smAshomash.org. Please don't pole vault the caldera. It could be unhealthful. Let's get back to solar data here. Here's the X-ray flux over the past 3 days. No major flares, although some B-class intensifications of the solar X-ray output. Proton flux not showing any spikes, nor any surprises there. At least, certainly not to our channel. And here's the GOES magnetometer, and we can expect to see this get a little bit jumpy here over the next couple of days. There is a heliospheric current sheet polarity crossing about to happen. The Earth may snap into a North Pole current sheet pretty much at any time, folks. That's the 3-day chart of the GOES magnetometer, and here's what we're talking about. The heliospheric current sheet. You're looking at South Pole-oriented current sheet in red and North Pole-oriented current sheet in green. It looks like by tomorrow when we do the daily space weather, we're going to see the North Pole current sheet at the location of Earth. So you can see the potential field surface source line here, this orange line from Earth. We're about to see it snap into a opposite polarity current sheet shown in green. It's the North Pole one. And we may see some activity south of the equator out by stereo A. We're not even going to worry about it as there's too much stuff to cover. So here's the line of sight ecliptic plane field plot. It's the same view just from the line of sight perspective. It doesn't quite show you as much insight as the top view ecliptic plane field plot, but we like to show it anyway to help people visualize what it is that they're looking at. It's the closest star and its magnetic fields. Here is the line of sight coronal hole plot. You can see that South Pole oriented coronal hole shown there in red, just rotating past the direct Earth facing zone, and another coronal hole system from the northern polar region, stretching down toward but not quite to the equator. We'll be keeping an eye on that. And when I say eye on, well, the pun is intentional. Next, the detected sunspot groups and filaments. And this is going to be named Sunspot 2830 today. It's looking quite significant. Although not large, it did appear almost immediately with a beta gamma class magnetic field organization. So Sunspot 2830, I'm calling it. Sunspot 2830. Detected filaments. not really detecting as many filaments as there are. We are seeing a filament right in this area. You can see that darkened region. Also filaments up here which aren't being detected because reasons. And yeah, so there are some filaments out there. We're not calling any coronal mass ejection warnings or anything like that, at least not at this time. The planetary K-index, a measurement of global geomagnetism, currently at 1, calm conditions. And let's take a look at the real-time solar wind. Pretty uneventful here over the past 24 hours. Current solar wind density, around 5.5 protons per cubic centimeter. Solar wind speed, very low, only 314 kilometers per second. Next, geospace magnetosphere movie. Here's magnetohydrodynamic pressure over the past 4 hours. And we're seeing the main pressure in the magnetotail region as solar protons get accelerated back out into the overall solar wind regime. And that extremely low speed solar wind coming in from your screen left there. Not enough to produce very much pressure in the bow shock region at all. And this is the bow shock region, by the way, for you new viewers. The sun would be out in this direction. And you're looking at two different images here. The Earth turned 90 degrees. So the equatorial plane is if you're viewing the planet from above at the pole. And the meridional plane is if you're viewing the Earth from the side, so to speak. Here is the other geospace magnetosphere movie that we'll show for today. It's the Geospace Delta B, ground magnetic perturbations. We show it daily, 4 hours of data, since we are currently experiencing a geomagnetic excursion. Leave us a comment and let us know what your theories are as to what the end result will be of the geomagnetic excursion. Will the poles snap back into the geographic areas? Will the poles migrate permanently? Let us know what you think in the comments. Anyway, there's 4 hours of data. Not a whole lot of magnetic perturbations here with this weak incoming solar wind. By the way, we do stream live regularly to Twitch. Maybe check us out there if you haven't done so. Twitch.tv/smAsho is the URL over there. The mobile app will notify you when we do put out videos. Although most of our content is on YouTube, check out our playlists as well, youtube.com/smAsho/playlists for all kinds of material you may not see in the daily space weather videos. Thanks for subscribing, everybody. If you're new to the channel, please press subscribe. Congratulations on finding out that our channel exists, and tell your friends, foes, science noobs, and science pros about the content. And please share on your social media. Let us know in your comments what your favorite social media is. Don't forget to check our links as well. We are also on BitChute. Did you see today's meteorology segment? Well, here's a clip. And notice the way the jet streams are staying all the way up around the U.S.-Canadian border here. And I think that's enough. And one of our many playlists is our meteorology segments. Again, youtube.com/smAsho/playlists for additional content. We're also on BitChute, thanks to our subscribers over there. Don't forget to follow us on Twitter. Will you be our 150th follower? Please check out our poll as well. We're interested in what you think about who is more important, Vladimir Putin or Joe Rogan. Currently, it's tied at 50-50. And if you want to know what we think about Elon Musk, again, check us out, twitter.com/smAsho. And we've just completed our cosmology segment. Make sure you check that out. It's not included in today's daily space weather video. Let's continue on to talk about electrons. Some of them are surrounding Earth. They have the capability of charging up satellites and causing satellites to shut down and communications errors and so on. We don't see any charging hazards. Here's the one-year chart of the electron flux as reported by Solon.info. And here is the 3-day chart. Low levels of electron flux here over the past 3 days. Forecast model showing even lower levels coming, especially with the coronal hole wind stream about to arrive. I would tend to agree with that forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Next day, visualization of the electron flux. Here's the total electron content forecast. And we tend to see more chaotic blobs of electrons here when we see low levels of electron flux. We see more coherent bands when we see higher levels of electron flux. And so once again here we're seeing a bunch of fairly anomalous electron blobs here over the nighttime portion of the planet. It's a common thing we see at low levels of electron flux. Anyway, that shows you where GPS errors are most likely to happen. Next, a diagram of the atmosphere, including the Van Allen belts and distances in miles, and another diagram of the atmosphere showing distances in kilometers, such as 300 kilometers there, the location of the F ionosphere layer. And here's the ionosphere, which is looking a little bit anomalous here over the past day. We're looking at 1 day of data here, and that is 1 hour per second. We normally show 2 hours per second. Let's actually reload that for the normal resolution. There we go. Ionosphere is looking a little bit anomalous right now. I don't know how else to explain it. If you watch the daily videos, you may be familiar with what this normally looks like. We're seeing a rather wide band of F layer. So these red areas, those are the F. That's when the F2 layer turns into an F layer. And at nighttime, the ionosphere becomes less vibrationally complex, I guess you could say. You're looking at vibration frequency here in megahertz, millions of vibrations per second. Here's the latest image from 10:15 Universal Time, actually looking pretty normal there at that moment as we approach Northern Hemisphere summer solstice. We did a meteorology segment today as well. Make sure you check that out. You can find all of our playlists once again at smAsho at youtube.com/smAsho, youtube.com/smAsho/playlists. And let's get to bonus features. First of which are the El Teide Spain ground-based solar observatory. You're looking at hydrogen alpha, which is 6,562.8 angstroms. One of the vibrational frequencies of hydrogen. Nothing to write home about there. Let's continue on with our bonus features. Here's Sunspot 2830. That's what we saw during show prep. And there are the fields. Again, you can see that it is already a beta-class sunspot. We've got a South Pole umbra trailed by some North Pole umbrae there, making it a beta-class sunspot. Likelihood of solar flares a little bit higher as a result of that. Let's press refresh and see what's going on since we did show prep. And it looks like it's stayed pretty stable here over the past about 40 minutes. Here's Sunspot 2827. You can see it's almost entirely degraded to an alpha-class sunspot now. And let's head over to Sunspot 2829. There's 2829. Still beta class. So you can still see that there are two distinct fields here. This one is South Pole. This one is North Pole. So that is still a beta-class sunspot group, and that still does have the capacity to produce some significant solar flares as well. Again, there are the fields. There are the umbrae. The trailing umbra still looking pretty weak here. Don't be surprised to see this downgraded to an alpha class later today as well. Thanks to our patrons, the real source of funding for the content. Our patrons are making it more likely that these videos will continue to exist and remain publicly visible. Thanks, patrons. We're also expanding our operation in various ways behind the scenes and providing all kinds of early warning data to our patrons. They find out about coronal mass ejections before they leave the solar corona. Do you? Do you watch our videos? Well, if you want to know about what's going on behind the scenes, consider becoming a patron at patreon.com/smAsho. And we'll close out today's daily space weather video with some close-ups of Sunspot 2827. In 131 angstroms, another one of the ionized states of iron. Fantastic view of Sunspot 2827. Here's a great view of Sunspot 2829, along with a great Earth scale there for perspective. And last but not least, the latest Sunspot group. So you should see the formation of this Sunspot 2830 happening here. It's been stable for the last hour. I think it's going to be named. Sunspots need to be visible in the Earth-facing portion of the solar disk for 12 hours or more to get a name. Anyway, thanks for tuning in to the Daily Space Weather. I've been your host, Dan, a.k.a. smAsho. Wishing you a delightful Sunday. Welcoming you to the Neo-Renaissance. And may that solar wind be at your back.